Alright, so this is problem 11.41, and it states the police officer is in a patrol car parked in a 45-mile-per-hour speed zone and observes a passing automobile traveling at a slow, constant speed. The officer starts his car and accelerates uniformly to 60 miles per hour in 8 seconds. And the officer overtakes the motorist 42 seconds after the automobile passed him. Knowing that 18 seconds happens before the officer began pursuing the motorist, determine A, the speed the distance the officer traveled, and B, the speed the motorist was traveling at. If we start and look at sort of a time lapse of what's going on, at time is equal to 0, the motorist right here is traveling at some constant velocity and passes this police officer who's just sitting right here. Now the police officer sits in the same spot for 18 seconds, so at time is equal to 18, the police officer, at this very instant, the motorist has moved from this initial spot somewhere over here, and the police officer is still in his initial spot, just starting to take off. And he accelerates uniformly to 60 miles an hour in 8 seconds and overtakes the motorist 42 seconds after the automobile passes him. So at time is equal to 42, the position of the motorist, which is somewhere out here, and the position of the police officer, which is at the same point, these 2 points are equal, is equal to some unknown distance, some x final. So how do we go about figuring this out? Well, we have to look at how the police officer moves. And we know he travels in two distinct ways. First, he accelerates for 8 seconds. So he accelerates, and this is really at this is 8 seconds of acceleration, and I'm going to put in parentheses the time that it is since the motorist passed him. This is 26 seconds since the motorist has passed him. If we try to figure out what the acceleration of the police officer is, because it's not given, we know the initial velocity is 0, so this is the police officer's information. The initial velocity is 0. His initial position is 0. We don't know his final position. We don't know his acceleration. And what are we missing? We know the time it takes for him to get this far is 8 seconds. From here to here is 8 seconds. And we know that the final velocity is equal to 60 miles an hour. And this is equal to 88 feet per second. The other really important piece of information that was given in this problem is that he accelerates uniformly. And what uniform acceleration means is we can use our kinematic equations. We can use our final velocity is equal to final velocity, initial velocity plus acceleration times time. The final position equals an initial position plus initial velocity times time plus 1/2 at squared. And final velocity squared is equal to an initial velocity squared plus 2 times the acceleration, I don't know what that is, times x final minus x initial. And these are kinematic equations for constant acceleration. So if we're looking at how to figure out his acceleration, we have to look at what we have and how it compares to these equations. And we have a final velocity, we have an initial velocity, and we have a time. If you go through and look at the equations, this is the equation you're going to end up using. So we have a final velocity, which is 88 feet per second, an initial velocity, which is 0, an acceleration, which is unknown, and a time which is 8 seconds. So our acceleration is 11 feet per second squared. So this is how far, or this is from this point to this point, the police officer is accelerating at 11 feet per second squared. Now, since we have this acceleration, we can look at what the next equation we need to use is to figure out, well, what is this? If this is x is equal to 0, what is this? X is equal to what? How far has the police officer moved? And we'll go through what we know, and the only equation that works is the second one. So we have a final position is equal to our initial position 0, plus an initial velocity, which is 0, plus 1/2 times our acceleration, which is 11, times the 8 seconds we've traveled squared. And this becomes, let me do this out real quick, 352 feet. This position is 352. So now let's fill out what we know. We know the police officer at 26 seconds is right here, and at 42 seconds is right here. So the total time that the police officer is traveling at a constant velocity from this point to this point is 42 minus 26, or 16 seconds. So we could figure out how long or how far the police officer travels by using this same equation again and using it with a time is equal to 16 seconds, because he's traveling with a constant velocity from this point to this point, which takes him 16 seconds. So x is equal to an initial x. Our initial x is, at this point, we're at 352, plus an initial velocity. At this point, he's moving at 88 feet per second, times the 16 seconds. And since he's moving at a constant velocity, this acceleration term goes away. And we can just calculate this, and x is equal to 1,760 feet. So the total distance the officer travels is equal to the distance that he travels when he's accelerating, which was 352 feet, plus the distance he traveled when he was moving at a constant velocity, which was 1,408 feet. And if you add these two distances together, you're going to get 1,760 feet. And finally, we're asked to figure out what the motorist speed is. To do this, we can use this equation, the same one we've been using with the police officer, and there's no acceleration term, so that goes away, and we can just plug this in and get our answer. So the motorist has moved a total of the same amount of distance that the police officer's covered. He's moved 1,760 feet. His initial position was 0, and his initial speed is constant, and is also his final speed, times the entire interval, which is 42 seconds. And we'll get what his speed is. So it's 1,760 divided by 42, and he's moving at 41.9 feet per second. And if you happen to want to convert this back to miles per hour, you're going to get 28.6 miles per hour. And that is ridiculously slow. I don't even know if cars can go that slow, but the officer had pretty good cause to pull this guy over.